Hi, I'm Brianna Meyer, and I'm going to be going over the polymerase 3 reaction and showing it to my friend Skylar.
Hi, I'm Skylar, and I watched Bri draw this diagram as well as she is not using notes for either the presentation or the diagram.
Okay, so to start this one, there is only one polymer, and adding the building block to it. And then the right side, the black side, is the template, the one that's upside down. Okay. And then the second carbon has no oxygen because it is deoxyribose, and that is these ones that are upside down there. And the first reaction, where the single binding blocks are being joined and RNA is being made and is being catalyzed by primase. Once primase has done its job, you know that the DNA polymerase is the one that makes DNA building blocks, and that is the one that is going to catalyze the reaction. Primase needs the template DNA, the one on the right. Same one. To be able to read off and to synthesize. The building blocks are triphosphates because you need the release of the triphosphate and the hydrolase to provide energy to make the delta G negative to allow the reaction to proceed spontaneously forward in that direction. And then these are the triphosphate groups. Okay. DNTP building blocks. There's a 3' OH group. The oxygen has a lone pair that allows it to attack the phosphate. So then this is, that's the oxygen with a lone pair, and it goes down to the phosphate group, and then it gets rid of that oxygen. Let's see. Since phosphate is already full, it has to release the other oxygen and give it back its lone pairs. And then we move down after DNA polymerase 3 to this. And then this is basically the same thing as shown before, but the difference here is that the phosphate has gotten rid of these two phosphate groups right here. They're still attached by the oxygen, and now the phosphate group is connected to the oxygen, which is connected to these. Okay. And there could be in these empty boxes, there could be either T and an A, or T and an A and a U, or a G and a C, and the G and the C have the triple bonds, and the A and the U could have a double bond. I just left them out because it wasn't specific on which letter should be included, just so this could be like an open diagram for anything. So it released the phospholipase and formed a phosphodiester bond, and hydrolysis is happening, and the lone pair is coming from the oxygen in a water molecule, as seen here. The HOH is coming to the phosphate, and it ends up with the two single inorganic phosphate groups, as in here they are no longer connected to each other, they are just by themselves. That's it.